Okay, so if you'd like to say it again, 3.5, and the problems are?
53 and 57.
Very good. So in 3.5, let's look at 53. Find an equation of each line described. Write each equation in slope-intercept form. Solve for y when possible. So in 53, it says a line passes through 10, 7 and 7, 10. So you were asked to find the equation. So what was difficult in this problem?
They didn't understand what to do.
Can anyone tell us what to do when we're given 2 points and we're asked to find the equation?
Point formula slope. For the point.
So I have to find the slope first. Yes.
So it's going to be that y2 minus y1 over x2.
So if this is x1, y1, and this is x2, y2, I have to use y2 minus y1 over x2 minus x1. And I will determine a number. And then?
Then it's the y minus y1 equals m parentheses x1.
Very good. Which point will I plug in? It doesn't matter. It doesn't matter. Because remember, when you go up the hill, it doesn't matter if you go downhill or uphill, or you go uphill or downhill, the slope of the hill will not change. If you consider 1 and 2, or you consider 1 and 2, it doesn't matter. The slope will be the same. So it doesn't matter which point you plug in. Becky, is this good enough?
Okay.
Is that clear? So this is x1, y1, this is x2, y2. So once you get this number, you plug them in, you get this number, and then you plug in the slope that you got right here, and any point you want. So either 10 and 7, 10 and 7, or 7 and 10. Do you think that this is good enough for 53?
Okay.
Yes? Okay, so let's look at 57. So you have the slope 1, and the point is negative 7, 9. Slope is 1 and negative 7, 9. So we are given the slope and we are given a point. That's the only equation we need. We're going to write it one more time. Y minus y1 equals the slope times x minus x1. And you only have to replace x1 by negative 7, y1 by 9, and the slope by 1. And then you have to solve for y. Do you think that that is good enough? Very good. Other questions? Anything else that you worked on? Anything else you had questions on? Anything? Anyone?
I'm concerned in homework if I did notes from like the 5 math labs, can I burn in the notes from that, or do I have to do other topics too? Because I did a lot of like the similar question ones.
That's fine. Whatever I can look at and see that you're on the right track. I prefer the ones that are recommended, because those you should have the solution from the beginning till the end. Yeah. Good. Other questions for me before we go back to 8.1 and then chapter 4? Anything else you worked on? Anything else you encountered difficulties with? Becky, are these okay? Okay. Good. So in that case, we go to 4.1. I meant 8.1, of course. It's all the same thing. It's a copy of 3.5. So graphing and writing linear functions. So 8.1. Very good. Nothing new. Everything is the same. Let's go to page 516, 517. What I would like to work on, something that I did not get the chance to work on last time, parallel and perpendicular lines. So let's look at problem 64. A line passes to 3, 5 and is perpendicular to 2x minus y equals 8. So we are asked to determine the equation of a line, and we are given two pieces of information. We are told that the line passes through the point 3, 5. So this is the line that I don't have. I'm looking for the equation of this line. I don't have it. But I know two things about this line. First thing I know is that somewhere I have 3, 5. And I also know that this line somewhere intersects another line and is perpendicular to it. And the equation of this orange line is 2x minus y equals 8. So I'm asked to find the equation of the green line. And now I'm thinking, I have only two equations of the line. I have the mx plus b, but I can use that only if the given point is 0, blah. I don't have 0, blah. So I cannot use y equals mx plus b. I can, but I shouldn't. Okay, so my other option, the only other option is y. We just wrote it twice. Y minus y1 equals the slope times x minus x1. And of course, I know the point. This is my x1, y1. So this is my 3 and this is my 5. However, I cannot continue. Why I cannot continue?
Because you don't have a slope.
Excellent. But is the slope given in any indirect way? Yes, the slope is given. How do I determine the slope of the green line? Careful. By
turning the given equation into a slope-intercept line.
Exactly. So this is the equation of this line. I must determine the slope of this line. By inspection, it's not good enough. So I have to do something to this to determine the slope of this line. I have to solve for y. I have to put this equation into mx plus b form. Then I will identify the slope. And once I have the slope of this line, how will I determine the slope of the green line? Or the product is -1. Or whatever, yes. So, what do I have to do here? Yes. So in the equation 2x minus y equals 8, I will move 2x in front of 8. So negative y equals negative 2x plus 8. And then both sides or multiply, just in this case is the same, divide or multiply by -1. And it has to be term by term. This divided by -1 is y, this divided by -1 is 2x, and this divided by -1 is -8. Victoria, you have to put that away. I have to see it in your backpack. No, sorry. And you have to close that and put it on the floor now. Sorry. And I would like you to tell us how to continue. How do we continue here? What do we have to do?
Then
Yes.
plug something.
Okay. What will I plug in? So the slope of the pink or orange line is how much? I'm going to call it M1. How much is it? 2, indeed. Now, how do we determine the slope of the green line then? I'm going to call it M2. Okay?
-2.
Okay, how much is it?
-1/2.
Very good. Because the product has to be -1. So 2 times -1/2 is indeed -1. Are you with me? Okay, perfect. So now I have everything. So please take 1 minute and find the equation. I have the point, I have the slope, I have to plug everything in and find y. Let's do it. The product is -1. If the slope of this line is 2, this slope must be -1/2.
So imagine a 1 underneath that 2, and then you just flip it. So you flip it and make it negative.
Okay, I understand that. Thank you.
Or you say the product is -1. 2 times -1/2 is -1. Good. So are you working on the equation? Okay, so this is y minus 5 equals -1/2 times x minus 3. What now?
You distribute.
Yes, y minus 5 equals -1/2 x plus 3/2. Very good. 1/2 times 3/1. Very good. And now I have to add 5. -1/2 x plus 3/2 plus 5. Are we okay so far? Do we understand these steps? Any questions? Let's stop for a moment. Any questions? Anyone? Tori, is this okay? Okay, with a slope. Okay, any questions? Danielle, are you okay? Any questions?
Just about the next step, like those.
From here?
No, like the 5 and the 3.
Oh, yes. So we find the least common denominator, which is 2. 2 and 1. 2. 3 does not need anything because it's a same number. If you want, you can consider 1. But 5 needs what? 2. Very good. So 1 times 3 is 3, plus 2 times 5 is 10, and the answer is 13/2. So then the equation is y equals -1/2 x plus 13/2. So can anyone tell us in words what we did? Let's summarize what we did, and what does this represent? So what did we do to get this equation?
Make the slope perpendicular.
Yes, this is the equation that is perpendicular to the given equation and passes through the given point, which was 3, 5. Perfect. But what did we do? Can anyone summarize the steps? Not just one person, just we can all contribute. What was the first step?
We start by putting it into.
Yes, the given point was, the given equation was changed into the slope-intercept form. Excellent. Step number 2.
Use the slope of that equation to find
The slope of the unknown equation. Excellent. That was step 2. Step 3. We used the point slope form by plugging in the point and the slope. Right. And then we solved for y. So one more time. Number 1, we solved the given equation for y in order to identify its slope. Step number 2, after we identify the slope in part 1, what did we do? We determined the slope of the perpendicular line. Once we had that, in step 3, we used point slope form. And finally, in step 4, we solve for y. Do we need to review this, or is it clear? Okay. So let's look at let's say 45. And it passes through -2, -3, and it's parallel to the equation 3x plus 2y equals 5. So we're asked to determine the equation of a line. Here's my unknown line. And I know 2 pieces of information. One piece is that it passes somewhere along the line. I have this point. And I also know that it's parallel to an equation to a line whose equation is this. Okay, 2 minutes. Javi, are you okay? Cheer up and let's work on this, everyone. Can anyone give us the first step? Solve 3x plus 2y equals 5 for y to find m1. So this is 2y equals negative 3x plus 5. So therefore y equals negative 3 halves x plus 5 halves. Remember, we have to divide term by term. Did we all get this? So what is the slope m1 then?
Negative 3 to 2x.
The slope has nothing to do with the variable. The slope is only a number. It has nothing to do with the variable. The slope is just one number. Perfect. So now in step 2, we identify M2. Can anyone give us M2 in this condition, in this situation? Anyone else?
3 over 2.
It's the
Negative
same.
3.
Yes. Yes. They are the same, right? It has to be, indeed, negative 3 over 2. It has to be the same. They're parallel. Good. Very good. Thank you, Matt. And 3?
Y1.
Exactly. Y minus y1 equals the slope times x minus x1. And I have the point negative 2, negative 3. Oops. Negative 2, negative 3, and negative 3 halves. Now I will write the equation and then simplify it in step 4 and solve it for y in step 4. So y minus 3, x minus 2. Now I will have to distribute negative 3 halves. Sorry about that. So I have negative 3 halves. X. Negative 3 over 2 times 2 over 1 will be negative 3. And I have to bring over another negative 3. So therefore the equation is negative 3 halves x minus x. Can anyone tell us what does this represent? So this is, if you want, step 4. We solve for y. Can anyone tell us what does this equation represent? It's the equation of the line that is,
Parallel.
yes, parallel to
3x plus 3.
and passes through.
Negative 2.
Negative 3.
That's it. Okay. We need to look at one more word problem. Yes or no? Yes.
Is it negative 6 or plus 6?
Okay, let's try again. So, is this step clear? Every time you have a thought that something may be wrong, you may be right. So, always bring it to my attention. I would always go back with pleasure and double check. I don't want to make a mistake, but it's possible. So, don't ever be afraid to say, I think there is something wrong there. I'm fine with it, or I really am. So, please, we are a team. We work together. Okay, so I plugged in, let me check, I plugged in negative 2, negative 3, and the slope was negative 3 halves. So then negative 3 halves, and this becomes x plus 2. Is that clear? And this becomes y plus 3. And now negative 3 over 2 times x is negative 3 halves. Negative 3 over 2 times 2 over 1 is negative 3. And this is a positive number. When I move it to the other side, it must be negative, because I'm subtracting 3 from both sides. And if I owe you $3 and I ask you for 3 more, now I owe you 6. Yes, honey? Yes.
For perpendicular line,
Yes, would have been?
would it be positive?
Exactly. Absolutely. Good. Other questions on this? Jackie, is this okay?
Yeah, I just added it.
That's okay. Okay, let's look at word problem. If you'd like to choose, you can on page 518, so we can move on to chapter 4. Are you proud of me that I know all your names now? I make an effort for that because I think it's a token of respect to you. So, yes. Any questions? Would you like to choose? Yes, Becky? From page 518?
Yes.
Perfect. Very good. 85 it is. Good. In 2010, so when I read, I take notes and then I read it again to make sure that I didn't miss anything. In 2010, the average price of a new home sold in the United States was $272,900. In 2005, the average price of a new home in the United States was $297,000. Let Y be the average price of a new home in the year X, Y average price, and X represents the year 2005. X equals 0 represents 2005. Write a linear equation that models the average price of a new home in terms of the year. And then use the equation to predict the average price of a new home in 2013. Okay. So we are told in 2005, this was the price, the average price, and 2010 it was this. And we are asked to create a linear equation that models the information we have in this problem. First thing I ask myself is what? Exactly, what is given in the problem? And yes, I am given 2 points, and I'm ready. Think of which one is the independent variable, think of which one is the dependent variable, and think of how to create those 2 points. Anyone?
The year will be X, 2005 will be the X.
X equals 0 represents 2005. We cannot use the name of a year in a problem.
Zero.
Yes, 0, 297,000. Excellent. Excellent. 272,900. Excellent. Perfect. What do I do next?
The Y2 minus Y1 over
Y2 minus Y1 over X2 minus X1. Please dictate. Label them carefully if you need to. Write X1, Y1, write X2, Y2 so you don't make a mistake. And tell me what to write.
Minus 0.
Say that again.
Over x2 minus x1.
Yes. 5 minus 0 for X2 minus X1. Perfect. And the top?
272. 900.
Yes.
I said that all wrong. Minus 0.
Minus 290.
That's why I labeled them so I don't make a mistake.
5. 297, yes. 297, yes.
Very good. Y2 minus Y1 over X2 minus X1. Perfect. What next? Can anyone give us the top? Say it again.
4,100.
Good. And the denominator is 5. So I will divide 4820. Without a measurement unit, this means nothing. The slope is a ratio. Its measurement unit has to be a ratio. The top measurement unit comes from the top. And the bottom measurement unit comes from the bottom. So negative 4820 what?
dollars per year.
Exactly. So the slope is a ratio. Its measurement unit must be a ratio. And it is, dollars per year. So what is the interpretation? Between 2005 and 2010, what really happened to the average price of homes in the US? The average price of homes between 2005 and 2010 decreased by per year. Excellent. Wonderful. Perfect. So I have the slope. Now what? I'm one step closer to determining the equation. I have to decide. I have two options. And I want to go with the simplify, the simplest one, if I can. Can I use what? Right, because I see that I have the y-intercept. So then dictate the equation, please.
Y equals negative 4, 4820. X plus.
Very good. See what a little bit of my math lab does, or my lab class does?
Yes.
Good. I'm impressed too. Thank you. Part B, use this equation to predict the average price of a new home in 2013. Never. I can never plug in the name of a year in a calculation. I shouldn't say never. I shouldn't say never. Some models will allow us to, but in general, we don't.
What is it, 8?
Exactly. So when x equals 8, which means 2013, I will determine y equals negative 4820 times 8 plus 287,000. And I trust you, just give me the number so we can move on. Say it again,
38,560. No, negative.
Not possible. It means that in 2013, the banks will pay us to live in a home. That would be nice.
Right.
258,433.6.
2584 through
33.6. Another 3.6.
Just be 258.
250.
Shouldn't it be hard since we're going down? Like, no. I don't think that's Is it too far?
So how much is it?
258,440.
258,440. Very good. So then the ordered pair is 8, 258,440 dollars. Perfect. Any questions? Any questions? Any questions here? Okay, chapter 4. Chapter 4 is all about systems. We already solved 2. So we're way ahead. So solving systems of linear equations. We will only look at systems with 2 variables and 2 equations and two, say it again. Oh yes, of course. So solving systems of linear equations. We will not cover the entire chapter. One section, which I think it's 4.4, we will not cover because it deals with systems of 3 linear equations in 3 variables. So we will only cover 4.1 through 4.3 and 4.5, which are applications. Okay. We already know what a system is. Allow me to copy one. I'm copying a system. You can indicate which one you want. On page 256. Page 256. Any problem you would like to start with from 13 through 42? I would like to start with something that is easy to graph first, and then we'll branch off from there. Any preference? I'm going to choose 38, and you can choose the next. So 38, y equals x plus 5, and y equals negative 2x minus 4. Okay. Because these two equations have to happen at the same time, there are two conditions that have to be fulfilled at the same time, we see two equations. And they both have two variables, right? xy, xy. Now, if I ask you to graph this, forget about the second one for a moment. If I ask you to graph this, how would you graph it? How would you graph this? What does it represent? Is it a circle? Is it a parabola? Is it a v function? What is it?
Line.
Of course. Of course. That's all I want you to say. It's a line. Okay, forget about the first one. If I ask you to graph this, what would you graph? Another line. Very good. So now let's discuss all possibilities here. When I solve this, I'll show you which methods, I can have one of the following three possibilities. Okay, so imagine this is a line, and this is another line. In how many ways can they face one another? This is one way. What does this mean?
Parallel.
Right. So if this is this line and this is this line, how many solutions will the system have? Absolutely, they never meet. These lines will never have a common point in which both conditions are fulfilled at the same time. This will never happen. They will never cross, right? No solutions. We call the system inconsistent. Good, that's one option. What is the other option? What are the other options?
Perpendicular.
Not perpendicular, but just cross. They don't have to be perpendicular to cross, right? They can be like this.
Intercepting.
Exactly. And how many points can two lines intersect? Exactly one, right? Okay. So this is the other option. We say unique, just one, unique solution. The system is called consistent because it has a solution. It's inconsistent when it has no solutions, but it's consistent when it has one or more. And the equations are called independent. So three things: unique solution, just one solution, consistent system, and equations are called independent. Okay, what is the other and the third possibility? This is one line, and this is the other. In how many points do they meet now? All of them. This is one line, and this is the other. So infinitely many solutions. The system is consistent or inconsistent? Of course, it has so many solutions. Consistent system. And the equations are dependent. infinitely many solutions, dependent equations, and consistent system. Okay. So this just says to us what are the options when I solve that. I haven't showed you yet, I did the other day, how to solve it. But I'm just telling you what can happen. No matter which method you use to solve, nothing else can happen but case 1, case 2, or case 3. There's no fourth in this situation. So now let's talk about methods. There are 3 methods. There are many methods of solving systems. Many, including computer algebra systems. Many methods. We will look at 3 methods here. 3 methods of solving systems of linear equations. Number 1, graphing. Number 2, we just did last time. What was it? How did we call it? When we solved the word problem with the rectangular parking lot, which method did we use for solving systems? Exactly. We substituted. We solved one equation for a variable and plugged it in the second one. And the third one, some books call it the addition method. I prefer to call it the elimination. It doesn't matter, you choose. I eliminate a variable. By substitution, the substitution is also eliminating a variable anyway. So elimination, I'm going to put in parentheses the adding method also. Same thing. Okay, so let's discuss all these. Now we have our system. I'm going to copy it again. Y equals x plus 5. Y equals negative 2x minus 4. Now, in the class setup, if I take this course, if I'm a student in this class, and my professor gives me a test, and the test says, solve the system by graphing, I can do whatever I want on scratch paper. I'm allowed to perform any operations I want. What I would do, I will solve the system by substitution or elimination. I will know exactly what solution to expect, if it's this, or if it's this, and then I will graph them. Why? Because I can never be 100% exact. If the professor gives me graphing paper, and it's easy to identify the points and see where they intersect. If they intersect, that's a different story. But I may not have that given to me, or I may not even want to try before I solve algebraically. This is what I would do. So since we already talked about substitution, let's solve the system and then come back and solve it by graphing it. Graphing the 2 lines and see whether they intersect or not, or they overlap. So if I use substitution as we did the other day, what will I do? Any suggestions here? Giving an idea not to exceed an hour for the video. So what will I substitute and for what?
Substitute that x with the x plus 5.
I don't have any equation solved for x. They're both solved for y. So I will not start by solving for x. They're already solved for y. So this y equals x plus 5. Well, this y has to equal x plus 5 also. So if I say to you y where I say x plus 5, I mean the same thing. So in the second equation, I will replace y by x plus 5. So I have x plus 5 equals negative 2x minus 4. They must be the same. It's the same y. It's the same variable. So if y equals x plus 5 and y equals negative 2x minus 4, those 2 quantities have to be the same. Do we all agree with that? Right? So this y is this and this y is that, but these two are the same. So these two quantities have to be the same. Now I know how to solve this. I will add 2x, I will move 2x, and I will move 5. When I move 2x, I get what? Very good. And when I move 5, what do I get? But it has to be negative. So negative 9. So then x must be negative 3. Then I go back and replace anywhere you want. That's the easiest thing to do. So if x is negative 3, how much is y? Exactly. So what is our claim really? That the system, is it case 1? Is it case 2? Or is it case 3? Is it case 1? Is it case 2? Or is it case 3? Absolutely. I found the point. I haven't checked it yet. But if I'm correct with negative 3 comma 2, it must be case 1. But I haven't checked yet. So I'm going back to the original problem, and I check negative 3, 2, negative 3, 2. Let's see if both conditions are fulfilled at negative 3, 2. If one of them is not, then this is not the solution. So let's try. Negative 3 plus 5. Does that equal 2?
Yes.
So the first equation is done. Now, negative 2 times negative 3, how much is negative 2 times negative 3? 6. How much is 6 minus 4? That's it. So there is no question. You don't need me to tell you that that's the solution, and I don't need you to tell me that that's. I went back and I checked. So this must be the correct solution. Right? Both work. Can two lines meet in 2 points? No. They either meet with one or all, but that's not the case. I'll show you examples when is this or this, but it's not that, right? This is 1 point. They intersect in negative 3 comma 2. Okay? Good. Now the problem is really asking us to graph. Solve by graphing. Now everything is easy. I don't have to guess on the graph. I already have done my work, my homework if you want, on scratch paper. And I know that this is the solution. So I have very little ambiguity, or none whatsoever, I should say. Good. So now I have y equals x plus 5. Yes, I have to determine the x and y-intercepts. When x is 0, how much is y? Good. What is the ordered pair that we just determined? Perfect. Now when y is 0, how much is x? Remember, you have to move 5 to the other side and it changes its sign. Very good. What is the ordered pair? Excellent. Now I'm ready to graph this line. Zero, 5. I need a blue. 0, 5. Negative 5, 0. Just remember, some of you just plotted 2 points without connecting the line. That's not a line, right? We remember that now, right? So this is the line. And remember to write the name. This is the name of the line. This is what I graphed. I graphed y equals x plus 5. Next, I do the same thing to y equals negative 2x minus 4. So when x is 0, how much is y? Good. So 0, negative 4. When y is 0, remember you have to move negative 4 to the other side, or you move negative 2x to the other side. So I move negative 2x, so I have 2x equals negative 4. 2x equals -4. 2x equals -4. So how much is x? Perfect. So -2 comma 0. So now I'm ready to plot the points. And I have -2, 0. And I have 0, -4. And I graphed y equals -2x minus 4. And now I'm going to look. I can see so well, and I'm so experienced with this. And I'll say, oh, very clear, -3, 2. No, I don't. It's very hard to read from that. But I did my work before, algebraically. It would be very, very difficult depending on, as you see, my unit here is not perfect. It's not the same with this. It's not the same with this. It's very difficult to read from such a graph. But I knew what it was going to be because of my previous work, algebraic work. And now I don't have to worry about it. I don't have to sit here and say, oh, maybe it's -3.5 comma 2.2. Or maybe it's -2.8 comma 3.1. No, I don't have to mess with that because I already had it. Otherwise, I would have had to sit here or stand here and look, okay, maybe it's this, maybe it's that. Let me check and go back. Any questions? Any questions? Okay. So let's look at substitution and then more elimination, which I didn't present yet. So let's look at on page 264. Let's look at problem 18. And this is 2y equals x plus 2. And this is 6x minus 12y equals 0. Okay, in the method of substitution, I have a note for you before we start. Substitution. Note. Substitute for a variable that has 1 or -1 as the leading coefficient. Do not try to substitute for y. Do not try to solve this equation for y. Because if you do, then you will have x over 2 plus 1. And you are replacing in here a fraction. And you don't want to do that. Most of the time, it will be more difficult than not. So substitute. Substitute for a variable. In other words, solve an equation for a variable that has plus or minus 1 as the coefficient, as its coefficient. Only. Not something that has 6 in front, 6x, or 5x, or 10x, unless you can simplify that number. Otherwise, I wouldn't. So, yes, I said simplify, simplify, simplify. And yes, I notice here that I can simplify this equation by what? Both sides by even more? Even more? 6. Very good. So I will rewrite the system as 2y equals x plus 2. And how do I rewrite the second equation after I divide both sides by 6? Yes, x minus 2y equals 0. And this is nice because I can get x from the first equation, but it's easier if I can solve the second equation for x. So if I solve the second equation for x, what do I get? Very good. And then I will replace it in the first one. What am I replacing in the first one, and how does the first equation look like using our substitution? It's 2y on one side, and what do I have on the other?
So
Of course, 2y plus 2. Very good. Because this was replaced by 2y. Okay, so now I want to solve this equation because it has only one variable. I know how to solve it. I will subtract 2y from both sides. What do I have on the left? What do I have on the right?
Two.
Okay, so if somebody says to you 0 is the same with 2, what would you say? You need help, right? So, no. So what is the conclusion then? Yes. Which case is that? Yes. How will I show that these two lines are parallel? I will determine their... Let's do that. I want to convince myself that I didn't make a mistake. So the first line is, so no solutions. Inconsistent system. No solutions. Inconsistent system. So now I want to 2y equals x plus 2. How do I determine the slope of this line? What do I have to do? Yes, divide both sides by 2. So I have y equals 1/2 x plus 1. And this is the slope of the first line. And here's the other one, 6x minus 12y equals 0. I want to solve this one for y. So I have 12y equals 6x. I can move this here and then read from the right. And then I will divide both sides by to get the slope. No, I have to solve for y. So I have to divide by 12. So then y equals 1/2 x. And this is m2. So now I know for sure I didn't make a mistake. These lines can never meet. They do have the same slope. m1 is 1/2, m2 is 1/2. It's definitely case 2. They never meet. No solutions. As we already obtained. Any questions? Any questions? Are we okay? Yes?
Question, so why didn't it become a -6 when you moved it over to the other side?
I moved the -12.
Oh, I see, okay,
So it's positive.
okay,
But I read it from here.
okay.
Good. Let's look at choose any problem you want. I would like to choose a problem with fractions as well, if we find anything. Would you like to choose, or I will? Okay, so let's say 36. Any questions? X equals 5/6 y minus 2, and 12x minus 5y equals -9. Yes, this problem is asking us to use substitution. Somewhere at the top it says use substitution for this. I would probably not use it in other conditions. Under different circumstances, I would probably not. But let's stick with the requirement and use substitution. Any suggestions of what to do? What will I do? I already have an equation solved for x. I'm done. This has to go in here. There is no question. I'm asked to use substitution. I have the first equation solved for x. It's given to me already. So in the second equation, I will replace x by 5/6y minus 2. Let's do it. So 12 quantity, 5/6y minus 2, close the parenthesis, minus 5y equals -9. Good. What do I do next? Yes, please distribute. I'm gonna stop the video and